Hello. This lesson is on section 3.2, polynomial functions and their graphs. So the polynomial function, when you multiply it all the way out, is a series of terms with x's added or subtracted. And these are called terms, and they have coefficients in the front. That's called the leading coefficient because the x to the fifth is the highest exponent, and then there's x to the fourth, x to the third, x to the 2, x to the 1, and the constant -6. So this is the leading term, and it tells you the degree of the polynomial. So the leading coefficient looks like should be 3. I'm going to make it a 3. And the degree is 5. So the leading term is 3x to the fifth. All right, and so the reason that this leading term is so important is because the leading term, because of its degree and its sign, it has the greatest influence on the end behavior of a polynomial function. So let's talk about the degree by looking here at this table. So if the degree of the function is odd, where this leading coefficient is positive and this exponent here is odd, then every polynomial is going to have this down-up end behavior. And if you want to write it this way, f of x is going to head to -infinity as x goes to -infinity. And as x goes to positive infinity, f of x is going to go to infinity. So we call this down up, and a is positive, right? So it's kind of like that increasing line. So if a is positive, it's going to go up from left to right, so down up. If you have an odd degree and a is negative, it's going to flip and go the other way. It's going to be up, down. So as x goes to -infinity, y is going to positive infinity. And as x goes to positive infinity, f of x is going to -infinity. So just like the translations we learned, if this number is negative, this 3, if this were negative, it would flip that down up over the x-axis and it would be up, down. So we learned that if you have an odd degree, they go in opposite, the ends go in opposite directions. Odd means the ends go in opposite directions. All right, even degree, you might recognize y equals x squared. That is an even degree. So that's the even degree is going to be up, up, if this a value is positive. And if this is an even degree, like y equals x to the fourth, and you have a negative in front, then that -1 is going to reflect it over the x-axis, and it's going to be down, down. All right, so the only difference between an x squared and an x to the fourth, like y equals x to the fourth, would look just like this, except it would start to look a little bit more flat at the base, the higher that even degree goes, but the end behavior doesn't change. So even degrees the arrows, the ends point in the same direction. Odd degrees, the arrows point in opposite directions. If a is positive, it's up, up. If a is negative, it's down, down for the even degrees. So you'll have to memorize that, but we're going to work on that a lot in some examples. Okay, so we can sketch the graph of a polynomial. If you know its y-intercept, we know how to do that. You set x equal to 0. Its zeros, those are when you set y equal to 0, and the multiplicity. So again, zeros happen when you set the polynomial equal to 0. To find the zeros, you need to remember the following terms are equivalent. Zeros are the x-intercepts of the related function. They're also known as roots, or even solutions if you were looking at an equation. And then this is really important. If c is a 0, then x minus c is a factor, and vice versa. So we'll talk about that as I look at the first example here. So our first example, what are the zeros of this function? Well, the first thing that I want you to notice is that you've got a -5 times x minus 3 times x plus 4 times 2x minus 1. So factored form is when things are multiplied together. So this is in factored form, this polynomial. And that's what we like, because when a polynomial is in its factored form, you see these linear factors. They're called linear factors because they're all degree 1 factors. So if we have something in factored form and you see all these linear factors, then the zeros, if you set this equal to 0, remember we're finding the x-intercept, so if you set that equal to 0, you would have -5 equals 0. And I'll come back to that. And x minus 3 equals 0, and x plus 4 equals 0, and 2x minus 1 equals 0. So the first thing, this is just to show you that -5 does not equal 0. So this is not a factor. This is a constant. It's just multiplied to the front. But this factor gives you 3 as a 0. And x plus 4, if you solve for 0, you get -4. And 2x minus 1, there's 2 steps. You have to add 1 to both sides and then divide by 2. So the zeros here are 3, -4, and 1/2. And I hope soon you can just look at the linear factors. If x minus 3 is a linear factor, then x equals 3 is a 0. It's the opposite of what you see. If x plus 4 is a factor, then x equals -4 is a 0. Now this one's got a coefficient, so the 0 isn't 1. It's 1 divided by 2, or 1/2. So when something's in factored form, it's really easy to see what the zeros are. So that's what this is saying here. If c is a 0, then x minus c is a factor. If x minus c is a factor, then you know that c is a 0. All right, before we can go to our next example, we need to talk about something called multiplicity. Okay, so the multiplicity has to do with what's outside the factor. So all of these, x minus 3, x plus 4, 2x minus 1, they all have this understood 1 as their exponent. Okay, so all of these zeros, for example, have a multiplicity of 1. Okay, so if you have a multiplicity of 1, then the behavior at that 0 or x-intercept is going to be straight through. If the multiplicity is odd, like if you had p of x equals x minus 3 cubed, see that odd degree there? That means that there's going to be something called a bend. So x equals 3, let me change the number. Let's do x equals 4. X equals 4 is the 0, and it has a multiplicity of 3. Therefore, if I were to graph the x-intercept at 4, then I know the behavior at the x-intercept of 4 is going to be a bend, because the multiplicity is 3. So let me explain how bends work. Depending on what your a value is, if you start underneath the 0, you're just going to be an upside down half u. And then at that 0, it's going to turn to be a regular u. This is called a change in concavity. So this is like a wire bending, and the cup that it forms is cupping down, and this now is cupping up. So again, if you start from up, above that 0, it's going to be a half cup up and then turns to a cup down. All right. Then finally, if the multiplicity is even, like if you had x minus 3 to the 4th, let's say. Well, we'll just do 2. We won't go further than 2. So if the multiplicity is 2, so if it's an even multiplicity, then the 0 is 3 and the multiplicity is 2. So if you graph the x-intercept 3, then when you see the multiplicity is 2, it's going to cause a bounce. So when you come above and you have to get to that x-axis at 3, it's going to bounce back up. But if you start below, when you get to that x, it's going to bounce back down. So multiplicity 1, straight through. odd multiplicity, which we'll just say is going to be m equal 3. We won't do any other odd than that. It's going to cause a bend. And multiplicity even, or we'll just say multiplicity is going to be 2 for that. It's going to cause a bounce. All right, and then one more thing, and then we can be ready to do our examples. You have to find the y-intercept, because these zeros that you're going to be graphing are the x-intercepts. Well, you need the y-intercept. All the time, to find the y-intercept, you simply let x equal to 0. So this y-intercept would be put 0 everywhere you see x. So that's negative 1/4 times 0 minus 3 times 0 plus 2 quantity squared. And we can use our calculator for that. So negative 1/4 times 0 minus 3 times, because it's factor, factor means multiplication, times 0 plus 2 squared gives me 3. So when x is 0, I get 3. So the y-intercept is 0, 3. All right. Use the value, use the a value, the degree of the function, the end behavior, the zeros of the function, and their multiplicity, bend or bounce, and the y-intercept to sketch a graph of the function. Okay, so here is our first example. All right, so if I give you a polynomial, your objective is to be able to graph that. All right, so the first thing we're going to do is we're going to need to find the leading term. And at this point, I need to tell you a shortcut, okay? So this is a video, so I can do this the long way. The leading term, you can tell what it is if this is all multiplied out, okay? So I'm really going to do this quickly, but I'm going to multiply it all out. So I've got negative 1/4 times x minus 3. X plus 2 squared is x squared plus 4x plus 4. So that's negative 1/4 times x cubed plus 4x squared plus 4x minus 3x squared minus 12x minus 12. Okay, so that's negative 1/4 times x cubed. And then we have like terms 4x squared and minus 3x squared, so that's x squared. 4x minus 8x is minus 8x minus 12. So then you distribute that negative 1/4, and so f of x is negative 1/4 x cubed minus 1/4 x squared plus 2x plus 3. So we did all that work just to get this leading term. Well, I have a shortcut for you. Hopefully you're going to stick with me. It is not necessary to do all this work because all we care about is the leading term. Okay, and the leading term is negative 1/4 x cubed. So here's the shortcut. As long as these are in the right order, x first, then all you have to do is take the leading term, negative 1/4, and multiply it times that x to whatever power, so that's x to the 1, times that x to whatever power, so that's x to the 2. And you get negative 1/4 x cubed. So you don't need to multiply all this out because I could care less about anything but the leading term. So all you have to do is multiply the constant times the leading term to the power times the leading term to its power. Okay, so the leading term is negative 1/4 x cubed. So go back to the front page and you've got to memorize this. The degree is 3 because it's the exponent of the leading term. All right, a is less than 0. Okay, so if it's an odd degree, it's going to give you opposite ends. If a is negative, it's going to be up, down. Okay, so the end behavior is up, down. Okay, the next thing we have to do is we have to find the zeros. Now this is already in factored form. So this constant doesn't give me, it's not a factor. X minus 3 is a factor. So 3 is a 0. And the exponent that is with that factor is 1. So that's multiplicity 1. So that's going to go straight through. Right? The other 0 comes from this factor, x plus 2. So that 0 is negative 2, but there's a square, so that has multiplicity 2. So that's going to be a bounce. All right, so we'll move on to the next thing. Remember the y-intercept? You set 0, you put 0 in for x, so that'd be negative 1/4 times 0 minus 3 times 0 plus 2 quantity squared. And you use your calculator for that. That's negative 1/4 times negative 3 times 4, which is 3. So we have a y-intercept of 0, 3. So now it's time to put all of that onto the graph. Okay, we're graphing a polynomial. So 0, 3, I'm going to plot that on the y-axis. And then my zeros, those are x-intercepts. So I'm going to plot 3, 0 and negative 2, 0. So that's 1, 2, 3 and negative 2. Now, I like to make a little note. At x equal 3, the multiplicity is 1. And at x equal negative 2, the multiplicity is 2. All right. Now, the last thing after all of that is you want to think about up, down. So I'm going to start up here and I'm going to end down here. That's what we mean by up, down. You have to know where to start. Okay. These are the only two zeros. Okay. So it should work when you get done. So I'm going to start by getting down to this x-intercept and its multiplicity 2, so I'm going to bounce. Then I'm going to go through that y-intercept, and it's somewhere convenient. I don't ever care where you turn around. I'm going to turn around and head back through that 0. And when I finish, I better finish as an up-down. Okay? So that's it. Now, occasionally people make a mistake. So let me show you what people do, and I'm just showing you so you don't do it. Let's say you know all the things. You know it's going to end up, down, but you forget there's a bounce there. So you go straight through. Let's just say you go straight through that, and then you go straight through that, and then you're like, oh, wait a minute, I got to finish down. And so when you make your correction, this is faulty thinking. When you make your correction, you go through the x-axis again. Well, if that's true, that means there's another 0, but there's only 2 zeros. So don't try to correct your mistake by crossing the x-axis again. You can't do that. Really, you want to find out that you forgot the multiplicity was 2. So don't make that mistake. All right, the more we do these, the better they get. So let's try again. All right, so this next one, f of x equals negative 2 times x plus 3 quantity cubed times 2x plus 1 quantity squared. Let's do it the shortcut. I hope you never feel like you need to multiply this out again. The leading term is going to be negative 2, the constant, times that leading term inside cubed, x cubed, times 2x. This is tricky. 2x. That's the leading term in there, and it's squared. So you have to do parentheses 2x squared. Very tricky. So that's going to give you negative 2x cubed times 4x squared. So the leading term is negative 8x to the 5th. That's the leading term. So that tells me that this is a 5th degree polynomial, and a is negative. So again, if it's an odd degree and a is negative, it's going to be in opposite directions, but it's not down, up. It's a decreasing function, so it's going to be up, down. The y-intercept we can find by putting 0 in for x, so that's negative 2 times 0 plus 3 is 3 cubed times 0 plus 1 squared is 1. So that's negative 20, that's negative 54. That's my y-intercept. And you can use your calculator for that. All right, now it's time for the x-intercepts, or the zeros, and they come from these linear factors. So x plus 3, you don't need to worry about the 3. The 0 is negative 3, but that's when you worry about it. You don't worry about it when you're solving it. You worry about it when you're thinking about what it's going to look like. It's m equals 3. The multiplicity is 3, so that's going to be a bend. All right, and then the linear factor 2x plus 1 equals 0. That's 2x equals negative 1. That's x equals negative 1/2. And it has a 2 on the outside, so its multiplicity is 2. So that's going to be a bounce. All right, so we have everything we need. We've got the x and y intercepts, and we have the end behavior. So it's going to start up and going to end down. And now here's an interesting thing. The y-intercept can get pretty big, pretty far away. So sometimes you might have to count by something other than ones. You can count by whatever you want. I'm going to count by 5s. So, and you can count different things on each axis. So I'm going to count by 5s on the x-axis. So -5, -10, -15, 20, 25, 30, 35, 40, 45, 50, 55. And then the x-axis, I can count by 1s. Doesn't matter. You can do different things. If you do different things, though, you do need to label. All right. So, -0, -54 is about right here. And then I've got my x-intercepts. X equals -3, but it's multiplicity 3. And x equals -1/2. It's multiplicity 2. That's getting kind of crowded here. All right, so I have my y-intercept, my x-intercepts, my end behavior. So I should end up down here if I start up here. So here goes a time to practice our bends. So it's an odd degree. It's going to bend. It's going to look like a half parabola, like that. And then it's going to turn around, and it's got to go through. This is tricky. It's got to, so this is interesting. This -1/2 is to the left of that y-intercept of 0, -54. So that tells me I've got to go get this -1/2 and really, and it's got to bounce and really be aggressive the way I managed to get that y-intercept. So that's pretty tough. So one of the things you can do if that's really bothering you is if you notice that you've got your zeros pretty close together, you don't have to count by 1s here. We could have spread this out a little bit like this. It's actually easier if you don't have any grid marks. So I could put the -3 right here and the -1/2 right here, and then bend, and then bounce, and just, if you're not burdened by the uniformity of those blocks, it can get a little easier. So I think on the test we won't have the grid marks. It won't be so hard to get everything on there. Okay, so on the back we have basically 3 examples. This one looks pretty straightforward. It's just that I might want to write that -1 out first. And then this one, for some reason, this x right here, people don't think that's a factor. That x just means x minus 0. So when you see x, that's a 0 of 0. It just bothers people sometimes. So just want to point that out. And then the last one that I want to point out is this is trying to trick you here. Look at this. X minus 3 is fine, but notice that the x term is in the wrong position. So that's going to affect you when you do your leading term. So you want to make sure you have all your factors in the right descending order. So I'm just going to rewrite this and ask you to make a note of that. So this 1 minus 2x is really trying to be -2x plus 1 is what it is. Same thing, 4 plus x, if we turn it around so that the x is first, that's x plus 4, quantity squared. Okay, so other than that, it's a good chance to practice. So again, I'm going to pause the video, fill in mine, and then you come back and check and see how you did. All right, if you weren't sure of yourself, just take a look at this first one. The leading term I got to be -1x cubed, so end behavior odd degree. A is negative. Odd means opposite. So up, down. Y-intercept, I put 0 everywhere. Multiplied, I got 0, -20. And then my linear factors gave me the zeros of 5, 4, and -1, and they all have multiplicity 1. Okay, now, so the reason I stopped is what I want you to think about is before you start graphing, like don't start way over here. Take a path through, and you can see that you're going to have to cross. I counted by 5s, by the way. You're going to have to cross through this -1, 0, and then hit 20. So it wouldn't be good to start over here because that's not the way polynomials work. They are very smooth when you go straight through. It's not perfectly straight, but it's, so you want to think about where you're going to start this first pass here. And then it doesn't matter where we turn around. We go back down through. So that is what your polynomial should look like. All right, try the next two, and I'll come back with it filled in. All right, so this one, how'd you do? I got a leading term of -3 times x cubed times x squared. So if you just add up these exponents here, so there's a 1 there, plus 3, that's 4, plus 2 is 6. So -3x to the 6th, that's an even degree, and a is negative, so that's down, down. And then I got my zeros with the multiplicities. And so down and I start here, and at this 0, I had to bounce because it's multiplicity 2. But at the 0 of 0, it's straight through. And then this is what a bend looks like. You're starting above. So you come, it looks like a half U, and then turn it around into an upside down U. So that's a bend there. All right, and then this last one, this leading coefficient was a little bit tricky. So first of all, remember what you have to do. I did it for you, but I want you to remember at start. You have to change these around so that the x is first. So I rearranged 1 minus 2x, I made it -2x plus 1. 4 plus x, I made it x plus 4. So my leading term is going to be -1/2 times x to the 1 times -2 to the 1 times x to the 2. And so -1/2 times -2, those are my coefficients, so multiply them together and you get a positive 1. And then if you add all these exponents, 1 plus 1 plus 2 is 4. So that leading term is 1x to the 4th, so my end behavior is up, up. To find the y-intercept, you put 0 everywhere you see an x. I got 0, 24. Okay, and now my zeros come from these linear factors. So x minus 3 gives me a 0 of 3. The multiplicity is 1. -2x plus 1 might need to come over to the side. So you subtract 1, then divide by -2, and you end up with positive 1/2 as your second 0, multiplicity 1. And then x plus 4 gives you the 0 of -4, multiplicity 2. So when it's time to graph, what I did is I counted by 4s here to get up to 24. It's still kind of an ugly looking graph. And maybe if I had to redo it, I might start kind of closer to that too, to make this a little prettier. But you have to go bouncing at -4. Got to go through the y-intercept, comes through that 1/2 because it's multiplicity 1, and then back up through that 3 because it's multiplicity 1. But I didn't create any new zeros, and my end behavior was up, up. Okay, in Blackboard somewhere is the key to this page, but we're going to move on and go the other direction now. Okay, well, I did do the key to this, and I did because I did see something right away. This first example here, notice that it's not in factored form. So in order to do these problems, you have to get it in factored form. But so this is not a hard one to factor. If you do it the long way, the factors of 4 that add up to be 4 end up being x plus 2 times x plus 2, which is x plus 2 squared. So that gives you a 0 of -2 with a bounce there. Some other things that I saw when you get down to number 5, did you notice, or make sure you notice that 4 minus x is not in the right form? I had to turn that around to -1x plus 4, which is going to affect my leading term. Same thing about this 3 minus x there. I didn't erase it. I left it as is, but I just kind of figured out negative 192 is too far down, so I just kind of graphed it there. But this one I did a better job. I erased it, and I said, well, it's going to be a lot prettier if I spread my x-axis out a little bit. So I counted by 3 blocks was 1. So I counted by thirds just to spread that out. And I counted the y-axis by 3s. So you may want to think about what to count by. All right, so try those. Now I'm going to end this video because it's already at 30 minutes, and we'll do a part 2.